Time to take a look at one of my favorite things, circles. Okay. Definition. Circle is a locus of points that is equidistant from one fixed point. AKA, you have a point, that's the same point away, that's the same point away, that's the same distance. Oh, look, it goes all the way around and makes a circle. Think of that little thing where you just take a string and you kind of like held it at the center and then went around. Like, oh, there it is. There are two equations of a circle we're going to look at. We have x squared plus y squared equals r squared, where the center here is just the origin, and the radius is just r. You take the square root of that number. Over here, this is the more standard form. X minus h squared plus y minus k squared, where the center of our circle is now h comma k. Right? The radius is still square root of r squared, which is r. Okay? A standard form of this circle is when you multiply out that beast on the right. You know, the x squares and y squareds and numbers times x and number times y's and constants. Okay. The first equation we said is the center about the origin. Okay. And the second one is centered at hk. But notice the sign change. It's always a backwards form. Okay. Whenever it's in parentheses, remember, it's always a little backwards. Remember when it was in the parentheses with the movement? It was always, if it was in parentheses, positive is the left, same with the right. Okay. It works the same way. So let's change the following circle equations and state their center and the radius. Okay. Well, here, center is the origin, so 0, 0. Its radius is just the square root of this number, which is just 5. Over here, this isn't in our standard form, but if we move it over by adding y squared, you can see it's in our standard form, and its radius is 0, or our center is 0, 0, but its radius is just the square root of 4, which is 2. Over here, it may have a 3 in front of it, but we can just take a 3 out of all of it, divided by 3. And that's x squared plus y squared equals 9. Okay. Its center again is 0, 0, and its radius is the square root of 9, which is 3. Easy peasy. Okay. Over here, we now start moving them. The center here is always the opposite of the sign, so 2, 3. This is the x and the y. And then the radius is the square root of 1, which is 1. Over here, the center is negative 4, positive 2. It's always the opposites. And then the radius, the square root of 8, which is 2 square roots of 2, 4. 4 times 2 squared of 4 is 2. 2 radical 2. Okay, yeah, you can get nasty numbers. Right. Last one here is not really in our circle center form, so we're going to move it over. So we have x plus 5 squared plus y minus 2 squared equals 9. Okay, making this a minus over here doesn't make it a circle or anything anymore. It makes it something a lot different. Okay, if we if we look at the center, it's just negative 5, 2. Remember opposites, and the radius is the square root of 9, which is 3. Just look at the equation, look at the form, get it equal to all the x's and y's on one side and a number on the other, and you can get it easily. Okay. So I have two wonderful little problems here that I didn't skip before. Let's just start with the bottom one. A circle passes through 7, negative 3, and has a center of negative 3, 5, right? The equation of the circle. Well, we know the center is negative 3, 5, so that'll help us. We're going to use our standard form. It's x minus h squared plus y minus k squared equals r squared. Well, x minus negative 3 squared plus y minus 5 squared. So it's really x plus 3 squared plus y minus 5 squared. The only thing we have to do is find the radius. Ugh, the radius. Well, the radius is the distance between the center and one of its points. Well, the distance for it really is the square root of x2 minus x1 squared plus y2 minus y1 squared. That is the distance formula. We take in the distance between these 2 points and these 2 points. It's the Pythagorean theorem, actually. You look at it. It's just, oh, how long is this? How long is this? Square and take the square root. Right? So in this case, our points are going to be 7. We'll call this x2. x1, y2, y1. It doesn't matter as long as you make sure that they are matching up. So x2 is 7 minus negative 3. That's the only reason why I did it, because it's going to make it 10 squared. If you did it with negatives, it'd be negative 10 squared. Still the same thing. Then we have negative 3 minus 5. Well, negative 8 squared. Okay, 100 plus 8 times 8 is 64. The square root of 164. Okay, well that is the radius. Well, what's nice is it's r squared. Well, it's the square root of 164 squared. Oh, it just gets rid of the radical for us. That's the nice thing about this thing. It gets rid of the radical, so we don't have to do any simplification to it. If we broke this down, we have to undo it, actually. Okay, let's do the other one. So we got that one too, because that's all I have in my problem set. Alright, see ya. Okay, the center is 2, 1, and it goes through 4, 6. So if the center is 2, 1, screw you out because I want to see you. It is 1, 2, I should say. We all know it's going to be x minus h squared plus y minus k squared equals r squared. Well, center's easy. X minus 1 squared plus y minus 2 squared. We just need the radius. Well, the distance formula. X2 minus x1 squared plus y2 minus y1 squared. Okay, that's a square. You can't read it. There we go. Now we plug in our points. We'll call you x1, y1, x2, y2, square root. X2, 4 minus 1 squared plus y2, 6 minus 2 squared. No problem. 4 minus 1 is 3 squared plus 4 squared. We look at that, we get 9 plus 16, square root of 25, which is 5. That's the radius. But remember, it's r squared, so we have to square it, so it's 25. Okay. So circles, all we have to look at is their general form. This is important. Remember, it's opposite. And usually we just got to find the distance between them. So it's going to need the distance formula. Remember, the distance formula equals x2 minus x1 squared. The difference of the x's plus the difference of the y's squared. It's added together, and then you take the square root. It's the Pythagorean theorem again. Okay, that should help out. Take it there.